Okay. Now we're going to do recap what have we done in the previous class. So we're going to do line balancing again. So under product layout, today we're going to do line balancing. So just recap, these are the parameters that you need to calculate when you do line balancing. And again, line balancing is a trial and error process. You find the optimum solution for that situation. So efficiency, basically you use this equation. You take the time divided by number of workstation, right, and workstation, multiply by actual cycle time. Okay. For workstation, number of workstation that you need to use, all right, that you need to design, you take the time divided by design cycle time. So these are the procedure when you do line balancing. First, you need to develop the diagram. So the diagram is called precedent diagram. So precedent diagram means there are some requirement for the process. For example, process A to process B to process C. So process B need to go through A first. So these are the requirement for the develop the precedent diagram. Okay, so it means there is a process that you need to go through before the next process. So need to develop the precedent diagram. Then you calculate the CD, desired cycle time. Then you calculate the number of workstation that I showed you just now, this one. Okay. Then you group your element together. You find the efficiency. So if the efficiency is not the desired one, you go back to the step number 4. So you group them together again, and then you study again. Okay, now previously we have this example. So we will go back to this example again and again. Because previous lecture, I think I rushed through. So some parts I didn't really touch very deep. So we having a factory that producing something. In this case, producing the this snack here. So some information given here is that there's a target to produce 6,000 strips every 14-hour weeks. Okay, so this is the target that you have, and convert all the hours into minute. So the first step, you will have this precedent table. Convert this table into a diagram. Okay, convert this table into a diagram. And the time also you included into the diagram. So how do you read this table? You will see process A, B, C, D, and then the requirement for that process. For example, A is required for B, A required for C, B and C is required for D. Okay. Precedence also means before you go into B, you need to go through A. Before you come to C, you need to go through A. Before you come to D, you need to go through B and C. The time for each process, A is this one, B this one, C this one, D this one. Okay, so how do you develop the precedent diagram? Always start with the first process in the factory. So the first one, you start with A. Then you look at the diagram here. After A, you will go to B and C. So just follow the next one. You just put B somewhere in a space and then draw an arrow for this precedence statement here. So if you see B need A, so you draw an arrow A to B. Okay, same with C. You can pick any space you want over here. So you just put C somewhere here. You can put here, 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 anywhere. So C, in the table, you need A. So you draw an arrow from A to C. Then you read D. Okay, you read D. So D need B and C. So basically D is here, or here, or here, or here, anywhere. but not here. Why? Because if you draw here, you're going to have an overlapping of arrow. Right? There's no overlapping of arrow in the precedent diagram. Huh? Your arrow must be clearly and only one way, no crossing of arrow. Okay? The shape, it can be changed, but again, no crossing of arrow in your diagram. So you can put D over here, or here, or here, or here, or even here. Okay? Again, no crossing of arrow in your diagram. So position behind A is not possible. So you follow this diagram. B, you need B and C, so draw arrow from B and C. After that, put in the time for each station, or not station, for each process. Put into the diagram. Okay. Now, basically, how many marks up to this stage? It will cost you about 4 to 5 marks for this precedent diagram. Location of each station, arrow of each station, and the time for each station. So minimum 4 to 5 marks, right? So 1, 2, 3, 4, 4 station with arrow and time. Okay. Okay. So after this one, any question for building the precedent diagram? Any question?
Doctor, the A precedes B also you must write.
Which one?
The
No,
A
no,
precedes
this one don't need. In your test or exam, don't need, this one don't need. It's just that I make a note here so that you know what actually happened to the arrow. Okay. In exam, you don't need to, or in test, you don't need to write this one. Important is the process and arrow and the time of each process. Okay. All right. So make sure you know how to transfer the information from table to the diagram. In test or exam, you have more process lah. Okay, you have more process. This is just a tutorial, so you only see 4. In exam, maybe you see 6, even 7 process. Okay, so it will take time to build the for your calculation also. All right. So next, you focus on the diagram that you draw. So basically, if you don't know how to draw diagram over here, basically the marks will snowball and the remaining parts will be wrong already. Even you accidentally mark the wrong time in the diagram, you will calculate wrong. Okay. Next, you work on the workstation, right? You build a table, right? So here you can find the design time, cycle time. Of course, in the question, if the question asks need to calculate this one, I will include in the question. Maybe in section A, calculate the design cycle time. So you design. Okay. B, okay, you draw. A, maybe develop the diagram. B, maybe I will state, okay, calculate the desired or design cycle time for the process. So CD equal to time divided by output. So remember, always change the hours into minute. Because why? Why change to minute? Because the minimum process or the smallest unit of your process in the table is in minute. Okay. So you change your target hours into minute. Then the desired cycle time is 4.4 minutes. After you get the CD, you calculate the number of workstation. N equal T divided by your CD. So the total times of all the process, so you add now. First one, second one, third one, fourth one. You add all the time, divided by the CD that you calculate. So always check your answer because it will always snowball from section A until section D. You wrong in section A or section B, you calculate one wrong number, it's going to snowball to the next session. So always check your number. Okay. once you find your n, let's say in this case is 2.5, take the next highest round number. You get 2.5 is 3. Let's say you get 2.1 or 2.001. You still take 3. Because this is the minimum workstation that you need. Okay, of course you won't get 0.0 something lah. Okay, you will get 2.4, 2.3, 2.1, for example. 2.1 still choose 3, because the minimum, if you get 2.1 and later you use 2 workstation, you won't balance the equation. Okay, always choose the next round number if there is a decimal behind. So just take note of this. Don't continue to use 2.5 in the answer. There is no 2.5 workstation in the factory. Either you have 1 workstation or 2 workstation. There is no half workstation. Okay.
So sir, anything above than 2, we take 3 straight, sir.
Means the next round number if you have decimal place.
Okay, sir.
Okay, because this is the minimum workstation that you need. So you imagine if you calculate 2.2 or maybe 4.2, you need 4.2 workstation. You can either have a full set of 1 workstation or no workstation at all. You cannot build 20% of the workstation and then put it there. So your worker will be confused. Why this workstation only have 1 screw or 1 spanner there and it's not complete one? So cannot do job. It's meaningless. So always use the next full number. So once you have your D and CD, then you can start working on your designing the workstation already. So you look at this diagram. So basically you're going to have 4 process and then you pack your process into number of workstation that you're looking for. So this is the minimum workstation you need for these 4 process. Then you can have your own way of calculating, but I'm recommending using a table. Okay, using a table like this. Okay, so you start with workstation, element, remaining time, remaining element. So this is just a draft. This is just a draft, and yeah, you can put this one by the side of your answer. All right. So if let's say you press the wrong calculator number in the number pad there and you calculate wrong, I will try to find some marks in your working. Okay. Yeah. So if you don't put any working there, I cannot help you. Okay. So I always start with first process A. So first process A, I put at my workstation number 1. So I built my workstation number 1 and then I put process A into workstation 1. So I put element A. Element A is 0.1. Okay, it takes 0.1, but my design time is 0.4. So I cannot, my process cannot more than, means one station cannot more than 0.4 minute. Okay, one workstation cannot more than 0.4 minute. So you put A already, so remaining time will be 0.1 and then maximum 0.4. So 0.4 minus 0.1, balance still have 0.3. So this one is the balance of the process because A already taken. So balance you still have B, C, D. Okay, B, C or D lah. Okay, but because why the next station? Because D you need B, C. So you just look at the next process, or you from the diagram itself. You can see it as a column, right? A first column, B second column, D third column. So after A, you go to B and C. You will not go direct to D. So that's why remaining element here, you only see B and C. Okay, D too far already, so you don't need to consider D. Consider the next process, B and C. So the remaining time is 0.3. You look at B and C. B and C, one is 0.2, one is 0.4. The remaining time you can fit inside station A must be less than 0.4 minutes, must be less than remaining time. It can be use up all this balance, or it cannot more than this one. So between B and C, we choose, if we choose C, 0.4, if we put C here, the total number spent in the workstation, combine A and C, will be more than 0.4. Because if you combine A and C, it will be 0.1 and 0.4, you get 0.5. More than CD is not good. So you choose B. Okay, you choose B here. Okay, so basically, or you can draw a small box left, small circle there if you want. But normally I won't do that. I will just look at this table and I choose the times that give me less than the design number. Okay. So in this case, I will choose the top one, B over here. Okay. So let's say you have a process that competing with the same time. Let's say this one C is 0.3. Let's say your C is 0.3. So you have two options to go. You can either go for put a B or put a C inside here, but my recommendation, always put the maximum process that take up the maximum first, so that you clear out the remaining time in the first workstation. You don't waste the time in the following station. Okay, I repeat. If you see a process that, in this one is a very drastic case where you have 0.4 and 0.2. That's why you choose B. What happened? I changed the value of 0.4 into 0.3. You can still use C over here. If your C time is 0.3 minute, you can put C here. I will personally prefer to choose C rather than B if your C time is 0.3. I like to clear out my time and then I put my B to the next station. Okay. So this is to me, that is the based on experience. So this one, if you have two values to compare, pick the maximum one for the next element. However, you must look for the remaining time. Okay. So if you put B, your remaining time here, it should not 0.2. Typo error again. This one, if you put B here, B is 0.2, remaining time is 0.1. So the first workstation, you still have 0.1 remaining time, but you cannot put in anymore, right? So you stop for workstation. So you fix workstation number 1. Remaining one, you still have C and D. So to choose between C and D, you know that the next process you should go is process C and not D. Because why? Because D process needs C. So without C, D cannot go. So the next process will be C. Okay, so you mark the first workstation. You circle, so put them together as one station. So A and B as one workstation. Then you continue with second workstation. I will go to C. So if you put C, what is the time you need? 0.4 maximum. Process C is 0.4. It will use up all the time you need. So 0, 0. So next element will be D. So you put D. So basically 3 is D and remaining time is 0.1. Okay, then no more element. Then you highlight the workstation. Or you just circle workstation. You can circle and then you write workstation 1, workstation 2, workstation 3. Okay, so this is how you group the workstation from N and CD. Okay, any questions so far for these steps?
So I don't understand how for element C the remaining time is 0.0.
Oh, okay. Okay, you understand up to here, right? You understand station 1,
Yes,
right?
up to B I
So
understand.
okay, so you already clear station 1 already. Now you want to set up a new workstation, which is workstation number 2, and you still have remaining C and D. Of course, you can put D here, but look at the requirement for D. What the D need? It need B and C. So if you put D here, there's no input from C. So the process will be a bit awkward. So you just follow the process. In here, I put C. So what is one workstation? What is the maximum time allowed? It's like a prepaid. It's like a prepaid phone. Maximum credit that you have is 40 cents, for example. And the call for one call for, if you make call for C, already spent 40 cents already. So what is the remaining balance? Is 0. It's like one workstation maximum you can spend is 0.4.
Okay,
0.4
sir.
minutes. Okay, then process C here, the time for process C is 0.4 minute. So when you put the process C in workstation number 2, there's no more remaining time. So it works as a one workstation itself. Right? So remaining is D. So after that, number 3, you know that number 3 is your last workstation that you can go. So if your N is 3, your table maximum number is 3. Don't go for 4. If your N is 3, here you write 4 means something wrong. It means you don't understand the concept of line balancing. Okay, N is 3 means in your table or in your design already use maximum station already. So 3, you only left out one station, just put D there. So when you put D there, the maximum time is 0.4 to spend. You put a process D there, balance will be 0.1. Again, there's a typo error in this column. This one is wrong, not 0.2 but 0.1, because the remaining time is 0.3. You put B is 0.2 minus 0.3, you get 0.1. Okay, so this will be the last workstation. You have 3 workstation there. Okay, so make sure you know how to line up your process. So from process into diagram, from diagram into number of workstation. Okay, from this table to the diagram, from diagram to the workstation. So you circle the workstation. After workstation, you go for diagram. Okay, so how do you build diagram? You use square, block, and arrow. So from the workstation that you circle in your diagram there, you combine A and B, right? So in the first block diagram, which is your workstation, is A, comma B. Then, if you combine A and B, where the product will send, it will send to C, right? After workstation, after your material go into A and B, which process it will go? It won't go to D, right? Because D, you need one more process, C. So you need a C in the middle here before you come to D. So you need to always refer to requirement diagram. So don't flip the D in the middle. If you put D in the middle, something wrong in your production floor already. Okay. Workstation 1, and put in the time there. Workstation 1, the time is 0.3 minutes. How you get 0.3? You combine A and B. So A is 0.1 minute, B is 0.2 minute. So A plus B, you get 0.3 minutes. This for workstation number 1. Then you go to the next station, you use arrow. Okay, or you can draw arrow from here to here. Don't need to show the tail also can. You draw arrow to the next station. So next station, you need to look at the precedence table. Don't put in the wrong process. It's not reasonable you put D after here, because D you need process C. Here, the product come to here, don't have C process. So D doesn't work. Okay, so if you put D here, the product will always send back to QC department. The QC will always reject your product because it doesn't meet the specification. Right? So you put C here instead of D. Because D you need process C. So C, workstation number 2, the time is 0.4. Then you go to the last station, D, 0.3. Yeah. Okay, yeah. So what we already done from the table into precedent diagram. From precedent diagram, we do some calculation using table. We work out the number of station or how we group the station by using a circle, right? Or using the table also, but I like to use circle because it's more graphical appear. So you can see the information straight away. So from the circle that you draw, you change them into box, become a workstation, and you draw arrow from the beginning until the end. Okay, so it should be show one direction of flow. Okay, one direction of flow. And no more arrow here because the process end here. Okay, so if you accidentally draw an arrow here, I put a question mark. What product come out from here? Okay, the process stop here already. So no more arrow come out from here. So you can calculate the efficiency by using all the information on this line diagram, assembly line diagram. Time divided by number of station divided by actual time. So time of all the process, okay, time of all the process, 0.1, 0.2, 0.3, 0.4, 0.3. So you put into the top one, divided by n. N is number of station that you calculate. Actual time, you pick 0.3, 0.4, 0.3. Pick the maximum time of station 1, 2, 3. Pick the maximum time among them. Okay, 0.3, 0.4, 0.3, maximum 0.4. Put this one inside actual time. Okay, so if you have 0.3, 0.4, 0.4, still 0.4. But if you have 0.3, 0.3, 0.3, then easy lah, here 0.3. But you have 0.3, 0.2, 0.3, then is 0.3 over here. Pick the maximum time. Okay. Any question on the efficiency calculation? Good. Okay. Then you get a decimal place. E equal to 0.833 is a decimal place, but percentage, you can put it a percentage, depending on the question. The question may ask you to calculate efficiency in percentage or efficiency in decimal place. Okay, if the question do not state what unit you use, both answer you get the full marks. You can put your answer in this one or this one. But if the question asks you to put efficiency in percentage, then this is the answer that the question asks for. And if you give your answer in 0.833, you do not get the full marks because the question, if the question asks percentage answer. Okay. Any question for example number 2? No, right? Okay. Next, we go for a little bit on the hybrid layout. Hybrid itself means you're mixing one or two type of the layout that we learned previously. Okay. So 3 type of hybrid layout you have here. You have circular, flexible, and mixed. Under flexible layout, you have 3 types: cellular, flexible, and mixed model assembly line. So we look at the first one first. For the cellular layout, it the objective of cellular layout is to focus on flexibility and efficiency. Okay, cellular layout, it focus on flexibility and efficiency. It try to find a balance between these two. And to remember what is cellular layout, we will use GT, group technology, GT, yeah? Those guys you are familiar, you are good in race car, then you think of GTR, lah, right? So GT is a group technology. What mean by group technology means you do grouping, right? You do grouping is like do sorting based on their function, similarity, and so on. Okay, so link cellular layout with group technology or GT. So for example, how you group your item in their respective function. So in the manufacturing setup under GT, under group technology concept, you group the similar parts together in the layout. Means all the process that produce a similar shape you put in that workstation. Okay. So for example, metal stamping, you stamp the similar circular shape. So all these parts will go through that particular workstation because the stamping will stamp out the different circular, and you only need to change the jig and also the mold for the stamping process, for example. Okay. Another one in the not manufacturing setup, maybe in the mall, or you can think of IKEA or IKEA. All right. So they also group their not IKEA, but yeah, IKEA also can. You think of a grocery, you think of a giant, right? So when they group their department together, they put the type of the fruit in particular section. Okay, the bread or related one, the wine, cheese, Europe, Europe, Europe food, or there's Western food section, for example. Okay, so link cellular layout with GT, with group technology, where you group things based on the similarity or based on the function, or right. So GT is grouped into machine or activities. Yeah, you group things together based on the machine and activities, machine or activities. And let's say you group this one into one group. Under GT, they call the group name as cell. Okay, when you group using group technology concept, those items that group under one similar group, cell is used, the name of cell is used for the group that you just assembly or you just put together. Okay, so every time you mention GT, then cell come into the answer. Okay, right. So this is a textbook definition for cellular layout, meaning you group your machine or cell based on the similar process. Okay, this is a textbook definition. But cellular, you think of group technology, how you group things together, or how do you do housekeeping, how do you do stock keeping. So you group things them together, right? Okay. And then during the cellular layout, or you do group procedure, pay attention to the movement of material between cell and cell. Okay, between one group to another group, we try to minimize the movement between the cell. Okay, because once you minimize the movement between the cell, you increase the efficiency of your layout. Okay. And what happens if you have a large machine to produce the certain process? So large machine, they are heavy and they are not flexible to move around. Usually, how they are being stationed when the manager use the cellular layout, they will put at the center usually, or they will put at the middle of the process where it can interact with other cell. Okay, so if you have big machine, you put in the position where it can interlink with other cell. Okay. Another term is called point of use. Point of use. Okay. The rest you can read. Okay. Now, if you're given a process like that, right? So this is a layout of a factory. You have a raw material. You have a process in the middle. And then you have an assembly line over here. Okay. So this is just a raw case before you do planning, a scenario before you do planning. So your raw material come in, go into the process in the production floor, and then you go into assembly. Okay, 1, 2, 3, 4, 1, 2, 3, 4 until 12 is a workstation. Okay, so if you study carefully in the diagram, you have this factory was divided the production floor into 4 sections or 4 departments slash the middle in the 4 department. Okay, raw material 4 department and then assembly. Or you can say there are four function department or 4 main process department in the production floor. And you can see all the lines here with color lines. It means the process used to assembly. So you see ABC there. ABC is stand for product A, product B, product C, or parts A, parts B, part C. So for example, you focus on part A. Part A need process, need workstation 1, then you go to workstation 2, you follow the red arrow, then go to workstation 4, then go to workstation 8, and then go to workstation 10, and then go to assembly. If you follow the arrow of B parts or parts number B will skip the first function here. B straight away go to number 5, then go to 7, then return back to, not return, but go to 11, 12, and then go to assembly and so on. Okay. So these are pathway that happen in the production floor. Yeah. So I just show you the parts A, B, C, how they produce in the production floor. So this one is quite chaotic, or this not orderly arranged. And if this one is a busy production line, you see there's a crossing of process over here. Here, if you have an experienced worker, then no problem because the movement can be synchronized. But you in a very new production line, you producing a new products or prototypes, this will be the area of accident happen, or there will be some product queue up over here because you need to wait for the traffic to cross and so on. Okay, so this is a raw scenario that you have. It's just elaboration. So if you have this kind of process, usually the workers, they are skilled at that particular machine. And if the worker is in this section, the worker can operate this machine, and this machine. Okay. So I put the diagram to the another corner. One new term for today called PFA, product flow analysis, is a method that we use to do um, line planning. Okay, so PFA is a group technology, a grouping technology, or group technology, GT. All right, it's a GT technique used to arrange your production floor like this. It's very troublesome, lots of crossing of lines. So you use a matrix to solve. Okay, you use a matrix to solve. For example, what is all this cross means? Huh? So if you look at part number one, if there's a cross there, means it need to go through that machine. If you read from parts A, parts A, you will go through station machine 1, machine 2, machine 4, machine 8, and machine 10. So you refer to the diagram. Parts A needs machine 1, machine 2, machine 4, machine 8, and machine 10. And throughout this matrix, you know that besides ABC, the producing up to H part in the process. Okay, starting with ABC, but in the production floor, you can find more than part C in the production floor. For example, D. Part D, although you do not see over here, part D, you need to go to station 1 or machine 1, machine 2, machine 4, and so on. Okay, so this one happened according to the process needed by individual parts, and each parts will require different process. This is just an example. Huh? So in this matrix, you do not see any pattern, right? You do not see any pattern for the routing, and you're not able to do grouping to improve the efficiency of the production flow. So there are some strategy to group this kind of situation or in the cellular layout. So we will use a routing matrix. There's a procedure to do this one into this one, but for this module, we will not go deep into this one because this one is a very complex procedure. Okay. However, there is a way to turn this scenario into this scenario where you can see the process of A still there, but you control the production floor process from 4 departments into maybe 3 process. First process, second process, third process, and it complete all the process in an orderly way. Okay, so there are some procedure to change this one into here, but for this module we do not include that. But for your information, there's a way, and you can use software to solve this one. Okay, so here also you can group this one into this pattern. Okay, it takes time to look at the raw data to come out with this form, and from here to here it might take you maybe 1 day, maybe a few weeks, just to observe the pattern. But with nowadays there's a software, with one click it will give you some suggestion. Okay, so from here to here, so from here you build the layouts. Okay, so you group from the raw matrix into 3 main process. Okay, for example, all this you group into one process. As you can see here, A go into here, and DF was inside this process. CG is over here. It used machine 3695, sorry, 369 machine. So that's why you align 369 for product C and G, and you align 5, 7, 11, 12 for product B, H, E in this one. So what happened to these two dots? This is these two dots consider not the major process, not crucial process, but you can fix the sequence for E to come into the production floor and then come out. So for example, E only involve machine 6 at one particular time, and then after this one you go into this section. Okay, and this dot also. For example, this dot is referring to G. So after G done in this process, it can send to machine 12 for finishing and then go into assembly. So this two dot is not a major critical process that it will affect the production flow, but you're focusing on 3 domain, for example, this one. Okay, so here to here or here to here, you need experience in observing the data. And of course, nowadays there are some very advanced mathematics software. They're able to solve metrics into organized presentation. Okay, so however, there are some basic idea. So for example, U-shape normally will be used for rerouting matrix. This is a U-shape. Okay, this is cell 1. When you do grouping technology, this is called cell 1, cell 2, cell 3. So for cell 1, you use U configuration or U shape of cell for the process. And this one also same, U shape. The benefit of using U shape is to enable rotation of workers. The workers can jump from machine to machine for the needs of the process. Okay, rotation of workers among several machines. So maybe the workers can come to one station 1, and then he can go to number 4 if needed, depending on the parts that go into the production floor. Okay, for example, product number 8, parts number F. F need machine 1, 4, 8. So if the workers that in charge of producing parts F, the workers can take the parts from machine 1, then go into machine 4, then go into machine 8 to produce part number F. Okay, so this is the benefit of using U-shape. And in the cellular layout again, if you are stationed in this cell, if you are the worker that's stationed in this cell, normally your skill or the skill that you have, normally you can operate machine 1, 2, 4, 8, and number 10. Normally you have the skill to operate all the machine inside the cell in one go. All right. So if you're stationed in cell number 2, normally your skill needed is to operate machine 3, 6, 9 in that particular shift. If you are the workers that stationed in cell number 3, meaning we expect the workers to be able to work on this machine, this machine, this machine, and this machine. Okay, so this is the characteristic of cellular layout. Okay, so this is an example of layout that you can find, okay, in the manufacturing's path. So how do you read this diagram? Layout always have in and out, so follow the arrow. In and out. When it go in, it go through a machine. Label the machine according to their function. For example, S is the saw, L is a lathe machine, and so on. So all these are machine. But observe the flow. The flow is only one direction. Although you can jump process, but the flow is only one direction. There's no counter direction. It's only one direction. You can jump from here to here. You can cut Q also, but the direction is one, from in to out. Okay, so outside one is how you rotate your material. Material go in machine one, and you can jump Q to machine two according to the process. The middle one is workers movement. Okay, middle one is the worker movement, possible worker movement. For example, if you are the green color workers, your movement for that particular shift, you walk in a triangular shape in one direction. Meaning you arrive at this station for your first shift, you work here, carry together with the parts, you work at here, 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 and then you go back. Okay, so worker number two, you work in a triangular shape also. Okay, so you work in a clockwise direction. You follow. Why clockwise? Because the material come in and out in the clockwise direction. So your worker always follow the product flow. So here you go up, go here, and go here. Also clockwise direction. So this worker, maybe it work on this machine. Go here, and go back. Okay, this worker also same, right? It's a different pattern also. So it means that in a circular layout, this is what is expected in the cellular layout arrangement. Okay, I hope you can get the idea of what is cellular layout about. Okay, the rest you can read lah. Advantages of cellular, there are a few. Again, cellular layout focusing on flexibility and efficiency. When you talk about efficiency, you talk about time. So what will affect the time is the material handling and transport time. So if you have a proper cellular layout like this, you're going to cut down the time need to spend in the production floor to produce the parts from raw material until the assembly. Okay, so this one you can read. The next one is that more on application. So within a cell, with it here, this is one cell. Within a cell, the worker is more likely to carry a partial finish along the process. Partial finish means maybe the parts only need machine 1 and machine 4. So in carry machine 1 product, after you use machine 1, you carry to this machine, and then it will go to maybe this machine. So this process, the parts that the worker holding is the partial assembly or partial finish in this process. Okay. Again, setup time again. Time again. Just now is the material movement, material handling time. Next one is the setup time. So in the cellular setup, you don't need to restart the machine and move the machine to other places. Okay, this is one of the strength or benefit of the cellular layout. Okay, the rest you can read. Next is you don't need a big inventory, right? You reduce the work in process inventory. You don't need to store your unfinished part. Okay, you don't need to store your unfinished parts somewhere in the store and then call the parts back to the production floor. Cellular layout improve the efficiency, so the unfinished part can flow into the production floor and finish in a shorter time to arrive at assembly area. Okay. Then this one is more on the human resource, because your workers, let's say you input or you put workers in cell 1. You imagine the workers can operate 1, 2, 3, 4, 5 machines in one day. So you don't need to train a lot of workers for each station, but maybe one workers it can cover 5 station or 5 machine in one go. Okay. Okay. Another one is more on flexible resource, because your workers can work in the cell number 1. It's flexible to switch over the needed material. Okay, more multifunctional, and it can adapt to the volume change. So let's say parts A the customer reduce the volume of this one. So maybe you can switch this operator, train the operator one more time, so that this operator can flip into producing maybe parts B, maybe this one, cell 1 or maybe cell number 3. Okay, means that you are more flexible to change your setup, your factory operation. Easier to control. This one you can read, right? And one good thing, if you arrange properly, you use group technology in your layout. You imagine your office is at the second floor or the first floor. This is on the ground floor. You only need to stand at the first floor or second floor and look down into the production floor. You can visually see how's the flow along the process. Okay, you can monitor the progress of your workers and also the production floor output. And if you already built a cellular layout, there's a high chances you can automate the process. Okay, it will prepare a platform for automation. So this is another example of automated manufacturing cell, where the cell will come in and then you use robot arm to process. So you can see at the center there's a robotic arm to process the whole thing. There is a disadvantages of cellular layout. Okay. Cellular layout is not for all type of products or all types of business. So when you have all these problems, when you have inadequate parts family, meaning that cellular layout you can only use when you have a similar parts, because you are using group technology. Group technology is group part based on their similarity. So if you have too many unit part, if the customer is ordering a new prototypes in the different, let's say you have 100 prototype to produce, then maybe this setup is not suitable. Okay, so you need to have enough similarity in the process, then only you can use cellular layout. Okay. It can only cater up to medium level of variety and volume. If your product is changing, or your product do not meet the similarity in a very different way, or the product shape is so diversified, then cellular is not for the process. This one is more on the planning. If you do not plan properly the cell, then it will create more problems. Okay, so this one need experienced manager and plant manager to go through very detailed observation on the cell. Okay, why? Because if you're observing the cell is actually producing the same result or the same shape or same function. You imagine if you do not, if your cell is not balanced, means suddenly you put in, maybe you employ a new workers and the new workers suddenly change cell number 2 machine into here. You try to imagine you accidentally you install the wrong machine in the wrong location for a cellular setup. You're going to screw up the whole process. Okay, if you try to imagine the new workers, suddenly you don't know somehow he's flipped the machine number 4 and number 6 here. Okay, means you flip the machine over here, you're going to screw up line number 1 or cell number 1 and cell number 2. Okay, and of course in the beginning you need training for your staff, because your staff need to know how to operate a several machine in one go. Okay, and if you're producing a very precision products, but usually the training will be very expensive. You need a very skillful and also increase capital. So you can see you group machine together. So if you're producing if you're the old factory, if you're old factory, you want to change into cellular, then you might need to change some of the machine to meet the cell requirement. Okay, it only economical apply when you have a new production flow. Okay, means that cellular layout always apply to a new factory setup. Old factory, if you want to use cellular, can, but you have to pump in money to change some of the machine so that it can fit into cell process. Okay. Can you guys go further? Do you need a break? You guys need break? Let's go for maybe 10 minutes breaks. I stop the recording.